but in a way in which the body can never be optimized further for that in a way in which we live.
Get ready to talk rocks with sedimentology expert Dr. Jürgen Grosch, the Indiana Jones of geology. He's on a mission to unlock a much overlooked energy source in the subsurface, natural hydrogen. We'll chat about the geochemical and biochemical processes in which natural hydrogen is produced from rocks in the subsurface and how tiny clues tell big stories about our planet's past and future energy solutions. Prepare for serious science jargon. We're diving deep into the geoscience research and the exciting world of natural hydrogen exploration. Jürgen, welcome.
Yeah, thank you very much indeed, Danis, for having me here. And as you mentioned it, allow me to say a few words about treasure hunters like Indiana Jones versus exploration geologists.
Exactly.
It is kind of a similar adventure indeed, maybe not quite as spectacular as in the movies. As geologists, we pick up these small clues and put together the puzzle of the subsurface without really knowing everything beforehand when we actually drill prospects for resources. Equally exciting when you see these results, success, partial success, or failure. You always need to explain the outcome for your next steps. And in case of a success, you are tapping indeed into a treasure, be it a critical raw material, mineral resource, or various energy resources. And natural hydrogen is one of these energy resources from the subsurface.
So, for the beginning, tell me, who is Jürgen Grosch? Because you have very rich past behind you and definitely a lot of experience.
Yeah, maybe let me say a few glimpses of what I've done in my long career in geosciences. I, at the end, worked as a postdoc at a university when actually I was approached by Shell to join their exploration and development for oil and gas. And that's what I've been doing for quite a long time, 31 years indeed, in various places around the globe, in international operations in the Middle East and elsewhere. After I've retired 1.5 years back. I actually joined the university, the Friedrich Alexander University in Nuremberg in southern Germany. That's where I've been working for like 15 years already to set up the geoscience, geoenergy master program for the university, because that is really where I think there's an important need for our societies, for our sustainable future, to have people who actually know about the subsurface and the importance of the subsurface for our future, present and future energy systems. So that's what I'm doing. Lately, most of the time I spend actually on exploring for natural hydrogen nowadays.
Natural hydrogen is a rather new topic, which has made the headlines recently. Why so late?
When you take a ferry boat from Tallinn in Estland to Helsinki in Finland, you actually pass by an island called Kari Island. There, actually, natural hydrogen was already found and used in 1907 to fire the lighthouse you see actually from the ferry boat. And in 1910, Ernst Erdmann, a German salt miner, actually produced hydrogen for 4.5 years in the salt mine of Leopoldshall near Stassfurt. All got forgotten for more than 100 years. And there's a variety of reasons for this. If you don't look for a resource, you don't find it, and if you don't expect it, you won't see it. And that is a kind of a story what we saw in unconventional gas and oil resources, which only were really explored for in the 90s. It took also more than 100 years until people realized you can actually produce from source rock hydrocarbons. Another reason is that oil and gas industry had already drilled environments, or rarely drilled actually environments where we see natural hydrogen predominantly, and that's Precambrian shields, ophiolite environments, mid-ocean ridges, deep basins. So that is actually also one of the reasons. And therefore, there's little chance to discover due to serendipity. And serendipity plays a key role. Maybe we can talk a little bit about later about this. Rapid growth of energy demand is another reason. Our economies and our societies are fueled by hydrocarbons. And there was a strong demand of continuous growth of energy demand during the 20th century. And yeah, that, of course, was the main resource, and nobody had really an interest to look into something else. Oil and gas was working for a long time. A fifth reason is mining industry. The mining industry is frequently active in hydrogen-prone environments, but doesn't always monitor actually hydrogen. They are in fact not really interested in hydrogen. They only see that as a risk in their developments. Sometimes there is explosions like in Albania, in the chromite mines of Bulice. They are due to hydrogen, so they can actually form a risk in the mining industry. And the mining industry is working at depths which are quite shallow compared to the petroleum industry. Yeah, and then we also see tool developments. We actually, yeah, we need tools to actually detect hydrogen. And if you look at the history of the oil and gas industry, a lot is based on gas chromatographs, which are sitting out on drilling rigs. But the interesting phenomena is that actually the carrier gas in these gas chromatographs, which were measuring hydrocarbons, actually is hydrogen. So yeah, if you have a carrier gas of hydrogen, you can't measure any hydrogen content in your gas. So these are kind of stories. Nowadays, we have very few portable gas analyzers actually, which do measure hydrogen. So hydrogen sensors are a relatively new thing. We can measure methane actually for safety reasons in portable tools, but actually hydrogen is a relatively new development. And then hydrogen is also very reactive, and it can form methane, so that or escape to the surface and into the atmosphere. Yeah, and then a lot of the literature which has been put together on hydrogen, natural hydrogen discoveries is actually in Russian. And yeah, before we got actually all these translators and AI, these scientific publications were hard to actually translate and read, and therefore they got ignored. An amazing history, even though actually the Russian geologist Vladimir Larin wrote a book about the hydritic world, which was published in English in 1993. But yeah, not a lot happened actually until recently.
Yeah, he has very interesting theory, and I watched a video, very old video, but very interesting. How do scientists estimate the amount of natural hydrogen emanating at the surface of planet Earth?
Yeah, many publications have been put together from various parts of the globe over the years, and then actually it was a Ukrainian geochemist in 2020, Skonik, who went through the effort to put all these publications together, especially the long ignored Russian publications. and made an estimate, and he came up with natural hydrogen emanations per year of 23 million tons from published
Wow.
data. That's quite a lot if you look at our annual production of gray hydrogen is 90 million tons. But others like the US Geological Survey, they think we actually have a lot bigger numbers, like they are talking about 100 or hundreds of million tons of hydrogen, which annually escape to the surface of this planet. And the real number has still a very high uncertainty range. But one thing is very clear, we have lots of surface emanations on planet Earth. And at the moment, almost every week, we hear about a new announcement from different parts of the world, like from Germany, Canada, Korea, Kazakhstan, Finland, and so on.
Yeah. What exploration techniques are best for finding natural hydrogen reservoirs?
Yeah, great question. It's yeah, first of all, and maybe surprisingly, it's serendipity. Um, yeah, the Mali Valley in the village of Burakabugu is such an example. A 100-meter deep well turned out to become the first global field development for natural hydrogen, now operating since more than 12 years without pressure depletion. Somebody threw a burning cigarette into the well and it exploded without flame in 1987, and then it still took more than 10 years until somebody picked up this information and generated the first long-term production site for natural hydrogen, and that's the venture of Hydroma in Mali. So yeah, I could tell you probably numerous such stories from the oil and gas industry, like from the discovery of the 10th largest gas field, hydrocarbon gas field in the world in the Netherlands in 1959 in the Permian Roodling sandstones. So serendipity is often the start of major developments in the energy industry, like the development of the European gas network centered around the Groningen gas field. But what we are nowadays actually are doing is to move into what we call play-based exploration for natural hydrogen, and that's where I have focused my work on with my experience and background, which means a systematic geology-based approach in our search for new energy resources. And thereby, in step one, we develop so-called play concepts. So a possible geological setting which allows generation and occurrence of natural hydrogen. We have developed 10 such play concepts up front, and as a second step, we actually search for such geological settings or plays using available surface and subsurface data in an area like in southern Germany. In our case, yeah, it's in the middle of the market, and so we can avoid one of the hydrogen dilemmas, which is hydrogen transport over long distances.
How big are these reservoirs? What could be the estimate?
That is another very good questions, and that is really one of the big unknowns. And the answer really is we don't know. And you have to realize that the natural hydrogen industry is at a similar point where the hydrocarbon industry was some 150 years back. It took us a long time to develop the understanding which we have now for the petroleum system and actually also the resources around it. So resource figures are very difficult, and particularly reserves figures are very difficult to estimate at this point in time. What we know is that there is a lot of hydrogen naturally coming to surface, predominantly along migration paths.
What factors influence how natural hydrogen is moving in the subsurface?
Yeah, that's indeed, that is there is similarities with the petroleum system. But yeah, obviously we know natural hydrogen can have a number of different sources, and these sources are, for example, serpentinization of ultra basic rocks. It's sources like radiolysis or better radioactivity in granitic, plutonic environments, or even earthquakes can generate natural hydrogen, and then it comes to the yeah, from the center of the Earth, which is the primordial theory of Larin. So we don't really know which one of these resources or sources is actually the main one. But what we know is actually that a lot of this hydrogen is moving from whatever source is the main one, actually to surface along fault systems, structural elements. And that is rather obvious also in the research we have been doing. And a lot of the hydrogen we see until now is from migration paths from these tectonic disturbances of the upper crust in the Earth. And the benefit is that these migration paths are considered regenerative. Uh, Therefore, they keep on feeding natural hydrogen continuously to the surface. So that is what we know at this point in time about migration of natural hydrogen.
What is the relationship between groundwater and natural hydrogen?
Yeah, what we see until now is particularly in the early startups is that most of them are actually doing brownfield exploration, what we call brownfield, which means that they drill near their new wells where they already know hydrogen is available from wells which the oil and gas industry mainly has drilled and considered in the old days as so-called dry wells or failed wells. So most of these old hydrogen occurrences, also in Mali, are from dissolved hydrogen in water or aquifer. Um, we are producing actually hydrogen from such aquifers, and that is part of the plate concepts. We have developed, the benefit is that these can be very shallow, like 100 meters in Mali or a few hundred meters in Kansas or southern Australia. These wells are low cost compared to oil and gas wells, which have to be drilled most of the time down to 3 to 4 kilometers in general. Therefore, groundwater or aquifers collect natural hydrogen, which is first way to migrate to surface, and that's where we can actually produce it from these aquifers.
Which geophysical methods are best for finding natural hydrogen?
In the first place, it must be said that the better the digital subsurface data, the faster we can work as geoscientists and evaluate the subsurface. This is a lot depending on good subsurface data management of the national geological surveys. Geophysical methods like 2D and 3D reflection seismic data or gravity and magnetic data help us a lot to get such better understanding of the subsurface. This is particularly important when you work in greenfield exploration, i.e. in the areas where you do not have previously reported natural hydrogen. That is what we are doing in southern Germany, quite successful by now.
What are the potential environmental risks of natural hydrogen activities?
Every well you want to drill requires careful planning and an assessment of what we call the potential drilling hazards. That happens in every well in the oil and gas industry as a routine, which can impact, well progress, costs of wells, but also safety and the environment. Natural hydrogen wells so far are considered relatively low risk due to their shallow depth and due to the fact that they are mainly drilled into saline aquifers, which are usually not overpressured. So pressure is not one of the key issues. Nevertheless, it requires that you always adhere to the existing regulator framework for drilling wells and that you do your homework and ensure safe delivery of such wells. The other thing is emissions, greenhouse gas emissions. And if you estimate them from natural hydrogen, it is a lot less than green hydrogen, which generates about 28 kilograms of CO2 per kilogram hydrogen. Natural hydrogen estimates go to zero 0.1 kilogram CO2 per kilogram hydrogen produced. So the emissions are actually a lot less than in any other energy resource we know at this point.
From the perspective of the molecule size, is the hydrogen does it have a higher risk in terms of environment?
The molecular size, it mainly determines actually on how fast molecules can migrate in the subsurface, especially in the small pore spaces we have in, for example, sedimentary rocks. We know that hydrogen is emanating to surface in large quantities. I've just mentioned this number of 23 million tons. That hydrogen is naturally in our atmospheric system incorporated. It is, of course, hydrogen itself is a greenhouse gas as well. So the more you can actually produce, i.e. not let it come to the surface, the better it is for our atmosphere.
So now one important question: what social and economic benefits could natural hydrogen bring? But in the same moment, what economical and geopolitical differences can it create in terms of what we have used to with fossil fuels?
Yeah, that's an important question, and that's also part of our concept, which we have built up to this point in time. Initially, it is expected that field developments of natural hydrogen are low margin business, similar to wind and solar. Maybe I will be proven wrong, but that's what we at the moment expect. But if you can find natural hydrogen in the middle of the market, like in southern Germany, where, for example, the local glass industry is urgently looking for low-cost energy, you can have a significant impact economically. As a second application example, you can envisage decentralized local energy production in or around local communities, possibly with synergies to geothermal energy, which allows these communities to become self-sufficient. This is what we call the prosumer model. So producers are at the same time consumers, involving communities, local communities in the production of energy. So that is a concept which is what we have in mind around natural hydrogen.
Sounds very interesting. Let's go a bit to the regulation side. There are not so many countries that regulate natural hydrogen, and those who do, either it's under the mining laws or under the oil and gas exploration regulations. So what regulations are needed for safe natural hydrogen development as a market?
Yeah, it's a difficult question, and you have put the finger right onto the spot. We don't have any such regulations for natural hydrogen in Germany. And if you talk to the Ministry of Economics in Bavaria, they say, right, it's not part of the mining law, and therefore it doesn't exist for us officially. And that is indeed similar in many countries. The regulator framework needs to be established, and it has to be quite different from the oil and gas regulations to make investments feasible, because, yeah, as I mentioned, we're talking about a much different type of margin business, low margin business.
And I'm still not even mentioning that the governments and officials are looking at it with one eye closed, especially in terms of incentives and investments. Am I right?
You are absolutely correct. It is not on their mind. And if you look at, like in Germany, the hydrogen strategy, it's all based on green hydrogen, pipelines, transport. The word natural hydrogen does not occur in the German strategy, hydrogen strategy for the future. And that's the situation at the moment, what we see in local ministries, in the federal ministries. The poll is not picked up until now. Yeah.
So you need to strike a big reservoir for them to get serious.
Yeah, it would be nice, but I don't think you need a big reservoir, which is not actually what we are planning for. What we are actually aiming for is smaller reservoirs or smaller emanations of hydrogen. But we certainly need to involve the government. Without the government, these natural hydrogen developments will not happen.
So there's a public perception of hydrogen in general. And I can already tell you that it's not so clear and it's still in its infancy. But I'm wondering, how can we explain the potential of natural hydrogen to the public?
Yeah, in principle, natural hydrogen is a very positive message for local communities and the public, not only looking at the environmental considerations, but also from a point of view that via the prosumer approach, everybody can benefit with respect to energy security, sustainable development, and hopefully also costs of energy. Communication will be vital, and we have to avoid non-technical risks in this, as we have seen them in the oil and gas industry or in unconventional developments, or also in onshore carbon sequestration projects. And therefore, involvement and participation of the public and local communities in natural hydrogen is going to be really important. And think about setting up cooperative environments, or think about the Stadtwerke München, which now earns a lot of money by producing its own energy it sells to its citizens, mostly geothermal energy in this case, and distributed by citywide heat distribution systems. Munich will be the first major net zero city in the world if they continue on the path they are now, and they make money. And that's a city-owned energy company, if you want to, a utilities company. That's what we need to think about also when we develop local natural hydrogen resources.
And that really sounds like a great plan. I've been speaking also to other experts around different topics, but you first go to the market adoption where it's most needed, and that's the end user. So basically, starting from the point where you are planning to start is really the right choice, and especially with the right fuel. What role can the natural hydrogen play in the shift towards a sustainable energy system?
Yeah, I can see it will become a contributor to the new future energy system. How big? This is still speculative at this point in time. Natural hydrogen can provide a sustainable, low emission energy solution and deliver energy security in the market areas, like, for example, in Germany. If you use it locally, you can also reduce a major challenge in our current energy system, and that is long distance transport via pipelines or shipping. one of the inherent challenges of our current present day energy system. One thing is clear, we have to develop a very different approach to resource development compared to oil and gas, to the oil and gas industry. We have to think smaller scale, think local, think community solutions, think local economy support. You don't hear people talking about this, but that is the concept we follow.
What are the biggest unanswered questions about natural hydrogen?
Oh boy, yeah, maybe let me give you three examples. One is what is the main source of natural hydrogen? We have so many choices that we actually really don't know what is the most important one. And then it's this question Larin has posed. Is there primordial hydrogen, which is quite possible? And if you look at the exoplanet research, recent work of the astronomers, they make us believe actually that there's a lot more hydrogen on planet Earth than we previously thought. So primordial, answering that question is important. And then, of course, what everybody would like to see, they would like to see a growing gas field as a conventional reservoir with traps, like we see in the oil and gas industry. Yeah, reservoirs may be there, but they will look different from the oil and gas industry, and we may not see the same what we saw there in the last 150 years. But yeah, reservoirs could be there. They can have different sizes, different types of reservoirs. That's what we still need to understand, and we don't know a lot about this at this point in time.
One of the questions that's been haunting me lately is there, except for Mali, any finding an exploration of natural hydrogen that's of that or higher significance right now?
Yeah, first of all, let me say, I don't think Mali is exceptional.
Yeah.
I think we're going to see a lot of Malis when we look in more detail around the planet. Maybe it's nice because it has very high percentages of hydrogen, but we can deal with that if it's less than 99% of hydrogen. So we will see a lot more of these type of occurrences of natural hydrogen in the subsurface, and that's what we need to look in the first place. That's what we are aiming at to replicate pilot projects like we see in Mali, elsewhere around the world.
How can countries collaborate to develop natural hydrogen resources faster?
Yeah, I've mentioned data makes the world go round of geoscience, and geoscience and subsurface data management will play a key role. Easy and fast access to digital data to allow for evaluation of play-based exploration concepts in a quick turnaround time will be important. And we see some promising, actually, activities from the geological services of Europe, and that's an initiative of the EU, which has been started by the European Geological Surveys, 37 in total, I believe. And they've started a project called EGDI, European Geoscience Data Infrastructure. And that is important because at the moment, we are dealing in geoscience with lots of complex data types in geology. And what we need is to overcome this and work with standardized data types, with standardized cloud-based data infrastructure, which allows us easy and quick access to subsurface data, which is hosted by mainly predominantly the national geoscience geological surveys or geoscience organizations.
What is the future outlook for natural hydrogen in the global energy mix? It's a bit too early for this question, but maybe we might estimate.
Yeah, I think I mentioned a little bit around it already. Yeah. I think it will be a contributor in the new energy system of the future. That's one thing. The potential for replication of small-scale local developments like the Mali type is certainly there for a global market. That's what I can imagine. Don't expect a 100 TCF Groningen gas field filled with natural hydrogen. I think these type of expectations I would be hesitant to raise at this point. How big the opportunity is will first require a series of pilot developments with proper production testing, which are not available at this point in time, besides from Mali. And that's not enough, with one little production site, we can't predict what's happening on the rest in the rest of the world. And that's what we are aiming at. We are aiming at developing more pilot developments, preferentially in an area with a market like in southern Germany.
So it's quite understandable that we're aiming for many smaller fields, but from the perspective of land usage and creating a network, say pipeline, for the transport of it, does that raise any concerns?
If you ask me, I would not start with this. Actually, transport of hydrogen is, well, in the first place, it's problematic. It
for sure
generates a lot of, or it requires a lot of energy to transport it. So it has a lot of downsides to it. So that's why I prefer actually this local solutions and local consumption concept, so that we don't need to transport hydrogen, natural hydrogen, over long distances. We have plenty of users. We have plenty of needs for energy. Hydrogen, if we find it, actually has many different applications. So it's not a problem to get it into the market if we work together with governments and communities, in fact.
How can combining different scientific fields help us understand and use natural hydrogen better?
Yeah, we definitely need to build our natural hydrogen strategy on two tiers. Tier one is what I call research, and that is to better understand the hydrogen system on planet Earth. Tier two is actually these pilot development projects I talked about to understand the production behavior and eventually enable us to do resource assessment for natural hydrogen. So many open questions which require a concentrated effort in academia and the future energy industry around natural hydrogen.
Can you explain the soil air sampling method and what you look for in the samples?
Yeah, that's a very powerful technology, which is based on really simply drilling or hammering small holes of 1 meter depth and 4 centimeter diameter, removing soil. And as a second step, actually, you quickly plug this hole with a tubing which enables you to pump out soil air, which is not contaminated or influenced by the air in the atmosphere. And as a third step, actually, you attach a handheld sensor to this tubing with an air extraction pump, and the sensor in the device can measure hydrogen, CO2, methane, and nitrogen, So that oxygen that actually is then also equipped with a georeference GPS receiver, and all this data from this sensor we actually extract it and transfer it to geographical information systems, which actually have various layers of geological information. Um, Outcropping formations, tectonic structures, etc. And then finally, we map the hydrogen concentrations as measured and perform the geological analysis in the lab.
What might explain the high natural hydrogen concentrations in soil air samples found in Germany?
Yeah, that was a great surprise, positive surprise to us. And the answer is migration paths, what we think. We have indeed found such paths in two different play concepts, which we consider as a major success, as there is next to none published locations in which such high concentrations have been reported. We are getting more recently, but that's quite unique what we saw there. And obviously, we had the right exploration concept in mind in the first place from our pre-study, and that's rather crucial for success. You need to understand your geological setting and your concept you are going after.
How can we encourage data sharing and collaboration in natural hydrogen research?
Yeah, we need to do this via scientific publications as well as via national geological surveys, which have to enable easy and fast access to data and distribute digital subsurface data. I think in the EU, GSEU, the Geological Services of Europe, is the right way to go. I think they need to establish these standards. We see a very good example in Norway. They have the Norwegian Petroleum Department and National, Geological Survey, if you want to call it like that. They do that very well. Also in the Netherlands, we have TNO. They also do that very well. Collecting the data from the oil and gas company predominantly, and then distributing it to the public or companies who are interested in exploration activities. So sharing, standardization, I think, are the two keywords.
How can we strengthen university industry partnerships for natural hydrogen innovations?
That is what we are trying to do at the Friedrich Alexander University, FAU. We have established a research consortium, which I manage with my colleague, Dr. Peter Achziger-Zubanczyk from the Fraunhofer IEG institution in Aachen. And this brings together the geo power of the main geoscience organizations in Germany. Next to FAU, Fraunhofer, we also have RWTH in Aachen, we have LIAC in Hanover, the Karlsruhe Institute of Technology, we have the Geoforschungszentrum in Potsdam, GFZ. So we formed a research consortium actually in the academic world, and we are in contact with a number of large and small energy companies and ask them to support our efforts. However, good things take time, and we are still looking for funding for these type of projects. That's an ongoing effort we are doing.
And finally, how can we inspire future geoscientists to work on natural hydrogen?
We need to do that. Absolutely. Correct. During my time as president of the Geological Society of Germany, DGGV, we realized that young geoscientists did not engage anymore with our society, and member numbers decreased every year, essentially. And this realization made us develop a whole program to engage with the young generation and young geoscience students by getting them into the board of the society, by starting a young DGGV division, by transferring responsibilities to them, by making them part of organizing the annual conference, by running geological field trips for them, by having them run part of our social media efforts, um, supporting the working group, looking after teaching of geology in schools, running webinars and more. This has helped us, and the member counts are going up as we speak again. But it's hard work. It pays off, and we need to get the interest of the young generation for geoscience. They will have to work out the subsurface contributions in the energy transition. And personally, I'm running a geoenergy class in the master program at FAU with all of our students, master students, and I'm teaching them natural hydrogen as one of the resources next to geothermal energy. And more students are getting interested in the topic. And our teams at FAU and at Fraunhofer IEG in Aachen are growing. We certainly need more students to get the momentum going and to catch up to 150 years of petroleum system research. We can't afford to take another 150 years to make this work.
It probably will be powered by AI, and you will be faster, I'm sure.
I think so. We have a lot more technologies that will help us, technologies which certainly did not exist 150 years ago. So, yeah, my hope is certainly that we are faster in 150 years.
Jürgen, thank you very much for being my guest today.
You are very welcome. It was very enjoyable talking to you. Thanks a lot for having me in your podcast.
We'll plan another one for sure.
Looking to amplify your brand in the hydrogen energy sector? Welcome to H2 Energy News, your go-to platform for impactful industry insights. Every month, we connect with over 80,000 visitors and generate more than 251,000 page views. Our reach is unmatched, with over 1.2 million web impressions and a loyal social media following of 9,000 plus. Our newsletter reaches 77,000 plus subscribers, decision makers, industry leaders, and innovators. Want to target specific markets? Our geo-targeting capabilities cover Europe, the United States, and the MENA region. We reach key stakeholders, 27% senior executives, 32% directors, and 20% owners and partners. H2. Energy News isn't just a news platform, it's where the hydrogen energy community converges to shape the future. Join us and let's make an impact together. Visit energynews.biz and take your brand to the next level.